Okay, so good day. My name is Jan Miguel Viganda, ID 125129958 from BSCE, and today we're going to tackle about the trig functions of any angle. So I would like to start with the special angles. That we know. So what are these special angles? So here we have 30, 45, and 60, because we can use them in the left hand rule. So imagine this is your left hand. This is your thumb. And this is your pinky. And label each finger from 0 to 90. So 0, 30, 45, 60, and 90. Okay, now for the sign, it's gonna be square root of the right over 2. And then for cosine, it's gonna be square root of left over 2. And for the tangent, it's gonna be right over left. Okay, so how do we apply this? First, let's start with sine 30. So sine 30. Okay, according to this rule, this is 30. Now, sine is whatever amount of fingers you have on your right side. So you only have one finger here, because this is your 30. So it's gonna be, let's erase that. So it's gonna be square root of 1 over 2. And what's square root of 1 over 2 is just equal to 1/2. So sine 30 is 1/2. Next, let's go with cosine 30. Again, let's look at your left hand. And how many fingers do you have here in your left? 3. So it's gonna be square root of 3 over 2. So that's it. And then now, there's a technique in memorizing this. So you can get the complement of 30, which is 60. And you just reverse the trigonometric functions. So basically what I mean is sine 30 is going to be equal to cosine 60. Let's check if it's equal. So here in 60, we're going to refer to cosine. Okay? So it's the square root of left over 2. And how many fingers do you have left? 1 in your left side. So it's going to be square root of 1 over 2 equal to 1/2. And same applies for the cosine and sine. That's why you have the word cosine. Cosine for complement. That's why they're the same. So sine 60 is equal to square root of 3 over 2, without even looking at the left hand rule. Oh, 3, sorry. Now what about tangent? Let's try tangent 30. Now, as I've said earlier, it's just a square root of right over left. So here in 30, you have 1, square root of 1 over 3 fingers left. So square root of 3. Or 1/3. Okay, now, we need to rationalize this in order to remove the square root at your denominator. So what you'll do is you'll multiply it by square root of 3 over square root of 3 to get rid of that square root. So it's gonna be square root of 3 over 3. That is your tan 30. Now what about tan 60? That's just gonna be somewhat the inverse of this one. So it's gonna be square root of 3 over square root of 1, or just simply square root of 3. Okay, because look, in 60, I'm gonna zoom it out a little bit. In tan 60 is square root of right over left. This is your 60, and how many fingers do you have in your right? 3. I have 3 fingers here, and then 1 finger here. That's why it's square root of 3 over square root of 1. Okay, so now let's proceed to 45. Sine 45. So now, 45 is just the exact middle of this. So you're gonna have 2 here and 2 here. So that means your sine and cosine are gonna be equivalent to each other. Let's try. So sine 45, referring to your left hand, you're gonna have 2 fingers on your left, and to the right, and then over 2. So that's it. How about cosine 45? What's it gonna be? So it's gonna be the same. The same fingers on your right and left. How about tangent? So again, since they have both the same amount of fingers, square root of 2, square root of 2, it's gonna be 1. That's your tangent. Tan 45. Let's move it a little bit over here. Okay, so now we have delved into the sine, cosine, and tangent of 30, 45, and 60. Now what about 90? And 0. Because you can see them in the left-hand rule, right? So imagine a Cartesian coordinate plane. So in here, you don't need the left-hand rule exactly. So now, this will be a unit circle, right? I'm gonna have a unit circle over here. So imagine that this is just a perfect circle. There. So this is gonna be your 90 degrees. And this is gonna be your starting point, 0 degrees. And we know that sine corresponds to your y value, and your cosine corresponds to your x value. So, since this is a unit circle, this is gonna be 1. This is gonna be 1 as well. This is gonna be -1, and this is gonna be -1. So now, what is sine 0? So sine is y, and we can see that there is no y coordinate in your 0 degree. So the sine 0 is just simply 0. What about cosine 0? Now that's gonna be 1. Why? Because here, it's touching the first line in your Cartesian coordinate plane, because this is a unit circle. And what about 90? Sine 90. We can see the y value of 90 touches 1. So sine 90 is equal to 1. And then your cosine 90 is equal to 0, because it's only along the y-axis. Now, what if you'll exceed an angle of 90? How are you gonna do that? Okay, still using the special angles. Now we're gonna utilize the use of reference angles. So, what are reference angles? For example, here's your Cartesian coordinate plane. What if you have an angle of, let's say, 150? So this is 150. 90, 0, 270, 180. What if you have an angle of 150? What are the trig functions of that? So basically, you're just gonna get the reference angle. What's the reference angle of 50? That's 30. From then on, you can just refer to our left-hand rule. So sine, let's begin with cosine. I guess that's the x. Now, cosine 30, according to our rule, is square root of 3 over 2. However, we're using cosine 150. So let's copy square root of 3 over 2. But now, as you can see, your x is over here in the negative x-axis. So it's going to be negative 3 over 2. But sine 150 is equal to sine 30. And it's just equal to 1/2. It's still positive because you're still here at your positive y-axis. Okay, so the technique there is first, check the reference angle. And second, check the location. So let's say we have find cosine of, let's say, 225. Now we know that 225 is in quadrant 3. So it's over here. Now what's the reference angle? It's going to be 45. Because 225 minus 180. So cancel that. It's going to be 12. So 5, 4. It's going to be 45. Now what is cosine 45? Is equal to square root of 2 over 2, right? But we're gonna find cosine 225, and cosine refers to x, and here your x is in a negative value, so cosine 225 is negative square root of 2 over 2. What if you have an angle that exceeds 360? For example, let's have an angle of 390. And we're looking for the sine 390. So what you're gonna look first is find a coterminal angle. Where theta is between 0 and 90. I mean 0 and 360. So how are you going to do that? So of course we're just going to subtract it. 360, which will give us 30. So now, since it's an angle that is less than 90, but more than x, or more than 0 rather, this is already your reference angle, or just the angle of 390, because they're just basically the same. This is your 30 degrees, and this is your 390 degrees. They're just the same. So again, you're just gonna look for sine 30. What was sine 30? That's just 1/2. Okay. So next, what about the inverse functions? So we know that sine, its inverse is cosecant, and cosine, its inverse is secant, and your tangent is cotangent. So how are we gonna do that? So basically, you just reverse the spots. So if sine 30 is equal to 1/2 cosecant 30, you just flip these two. So it's gonna be 2/1 or 2. What about, so cos 30 is equal to square root of 3/2. Your secant 30 is gonna be 2 square root of 3. So, but we need to rationalize this. So 3, which will end up with 2 square root of 3/3. So that's just the difference. Okay, let's try cotangent. So tan 30 from our rule is gonna be square root of 3/3. Cotangent 30 is gonna be 3 over square root of 3. Multiply both sides by square root of 3. It's just gonna be 3 square root of 3/3. These two cancels, so it's just gonna be square root of 3. So that's it. You just basically reverse the spots. So let's have an exercise. What is cotangent 270? Now referring from your unit circle and your Cartesian coordinate plane, 270 is over here. So we know that the y component is going to be -1 and your x component is 0. So let's first check the tangent. So tan 270 just y over x, or sine over cos. So it's gonna be 0. I mean, it's gonna be undefined. How about cotangent? So it's gonna be 0 over -1, or just simply 0. It's gonna be 0. Okay. So now, what if we're looking for cosecant? Let's think of an angle here. $4.95. It's a big number. So first, let's just move it over here. So first, what we could do is get a coterminal angle, since it's greater than 360. It's greater than 360. So now, subtract 360. We're gonna have 5, 3, 1. We're gonna have 135. So cosecant 135. Now, we need to get the reference angle. Since it is in quadrant 2, it's going to be 180 minus 135, or in short, 45. Cosecant 45. But let's check where is this angle going to be. It's going to be in quadrant 2. So, cosecant is just the inverse of sine. And sine is going to be your y value. So here, it's in the positive y value. So what is cosecant 45? First, sine 45 is square root of 2 over 2. Just take the inverse. So 2 over square root of 2, or the reciprocal rather. And then we're gonna rationalize it. It's gonna be 2 square root of 2 over 2. We can cancel these. So cosecant 135, or from your original one, cosecant 495, is gonna be square root of 2. Positive because it's still in the positive axis. What if you have this one? You're tasked to find tangent of a negative angle. So how are we going to do that? But first, let's take an example. So let's say, what if negative 45? So, in a positive way, you're going to return counterclockwise. But since it's a negative number, I'm going to start counterclockwise. So, your tan negative 45, or negative 45 degree, is going to be over here. Or another technique I would like to use is just subtract it from 360. So it's 5, 2, 5, 1, 2, 215. So that's it. I mean, 315. My bad. That's why I got puzzled. 360 minus 45. It's gonna be 315. So it's just the same as positive 315. And this is your negative 45. But it's way easier if you get this one, because it's already the reference angle. So it's just basically, what is tan 45? Again, what is tan 45? So it's gonna be square root of 2 over square root of 2, or 1. However, it's in the fourth quadrant. And here, your x is positive, but your y is negative, which makes your tangent negative. This is negative over positive, negative. So, in short, tan 45, negative 45 is equal to negative 1. Now, what if you have an angle, let's say, sine 15. How are we gonna find that? So we can use either the double angle and half angle, or the sum and difference. So let's try the half angle. So sine 15 can be expressed as sine 30 over 2. And then we can rewrite this as positive negative square root of 1 minus cosine theta over 2. Let's plug in the values. So we're gonna have square root of 1 minus cosine 30 over 2. And cosine 30 is just square root of 3 over 2. So now, simplifying that, you're gonna have 2 minus square root of 3 over 4, which is just equal to square root of 2 minus square root of 3 over 2. So that's your sine 15 using the half angle formula. What if you'll use the sum and difference? Now sine 15 can be expressed as 45 minus 30. So your sum and difference rules is gonna be sine 45 multiplied by cos 30 minus cos 45 multiplied by sine 30. So sine 45 is square root of 2 over 2, and cos 30 is square root of 3 over 2. Square root of 2 over 2, sine 30 is 1/2. Now multiply all of them. You're gonna have square root of 6 over 4 minus square root of 2 over 2, which will be square root of 6 minus square root of 2 over 4. And this is 4. Okay, but notice that we got different answers for sine 15. But remember, these two are actually just the same. So square root of 2 minus square root of 3 over 2 is just equal to square root of 6 minus square root of 2 over 4. Don't be fooled, they're just the same, because both are equal to sine 15. So let's just prove it. How are they equal? So let's say square root of 2 minus square root of 3 over 2. So you need to square this. So it's gonna be 2 minus square root of 3 over 4. So keep this in mind. Now we also square the other one. Square root of 6 minus square root of 2 over 4. So it's gonna be 6 minus 2 over 16. Oh wait, it's gonna be 6 plus 2 minus 2 square root of 12. It's gonna be 8 minus 4 square root of 3 over 16, or 2 minus square root of 3 over 4, making them equal. So that's it. And thank you for listening.